Alright, in this video we're going to begin looking at rectilinear motion problems in the context of antiderivatives and derivatives, problems that we've done in the past. So here on the schedule you can see that we have done antiderivative problems and differential equations, and I'm going to now talk about antiderivatives and differential equations, but now in the context of something called rectilinear motion. So in this video, we're not going to do really any math. I'm just going to show you some videos and plant some visuals in your mind for what rectilinear motion might look like. And then we'll do the math in the next videos, okay? So some of you I know are maybe not familiar with the fantastic video game called Pong. So we're just going to look at this as an example of rectilinear motion. So here's just a quick little YouTube video on Pong, and we'll play this now. And this is just a video game where, back in the old days, there's just very limited graphics and stuff, but we have two little Pong paddles. These are the little vertical bars, and they are trying to knock a ball back and forth. And you can see that the Pong paddles can only move up and down. They're very limited in their motion. They can only move in, say, one direction, but they can move up and down. Okay? So that is essentially rectilinear motion. Each of the Pong paddles can only move up and down, and if you turned your head on the side, they would only be moving left or right. Okay? So this is rectilinear motion at its finest. We've also seen rectilinear motion before when we had the person like jumping off of a cliff and into a waterfall, water below. That was also rectilinear motion. There was only one direction of motion. As time progressed, the object was falling down. Here, as time moves on, the Pong paddles can only move up or down. Okay, so let's take a look at, we'll pause this video and then start to transition over to some math behind this, okay? What you're seeing in red here is a graph of a function called 6 times the sine of t, okay? And as time progresses, as time moves on, you can see that, well, hopefully you can see, sorry, the graphics are a little slow here for some reason. So 6 sine of t, we're moving along the sine graph as time on the x-axis changes. And this is something that we are familiar with. One thing we need to see is down below, focusing on below, that we can kind of see a Pong paddle problem. The little red dot is like the Pong paddle, and as time changes, all we're seeing is that right here at time 0, can you see that our Pong paddle is at position on the y-axis, position 0, and then as time moves on a little bit, right, we can see that now our Pong paddle is at position 4, and that's why there's the red dot at 4, looking at the y-axis of the sine graph. And then at some point right here at a certain time, will be at the biggest value of 6 sine of t, which is 6. So that's where we have our maximum position of 6. And then as time moves on, the Pong paddle is now going to start moving to the left, right? And then at some point, right, we are the farthest to the left we can be at -6, and then the Pong paddle moves back to the right. Okay, but still negative. So one thing we need to see is that as we play this, we can see that we have an object moving left and right, right, according to the position function, 6 sine of t. We can also see that there is another function in black given by the derivative of 6 sine of t, which is 6 cosine of t. And it is this graph, the derivative, that will tell us if the Pong paddle is moving to the left or to the right. Here we can see that we are at this particular time, we are at position 4, but the derivative is also around 4, and that is a positive number, which indicates that the Pong paddle is moving to the right. The object is traveling to the right. Now, something interesting happens here when the derivative is equal to 0. When the derivative is 0, the Pong paddle, or the little object's position, was as far to the right as it was going to be, and after this point the derivative goes negative and indicates that our object needs to be traveling backwards to the left. We need to be going to the left now whenever the derivative is negative. Now at some point the object will stop again. You can see the object getting slower and slower until the object stops here at its farthest position to the left, and then when the derivative becomes positive again, the object is now traveling back to the right. So here we have just a reinterpretation of the function and the derivative. Here the function, which is in red, is controlling the position of the red dot, and the derivative of the function, rather than being the slope of the tangent line, is giving the velocity of the object, and positive velocities indicate that the object is moving to the right. Negative velocities means that the object is traveling backward to the left. So this is rectilinear motion. We can see an object, red dot, moving in only being able to move in only one plane of motion, so to speak, left or right, just as the Pong paddles were moving only up and down. So what you were doing here with the Pong paddles is trying to control the function in red to make the paddle end up at the right place at the right time to knock the ball. So ends this introduction to rectilinear motion.